All right, here we are. We're going to solve a vector addition problem, and it's question 4 on page 137 of your workbooks. I'm going to be constantly referring back to these big ideas. As you're doing a vector addition problem, you've got to constantly check that you're doing these big ideas as you go through, because most of the mistakes are when you don't do these things. In other words, if you're adding vectors together, you've got to make sure they're tail to tip. The arrowheads need to be on your vectors, and you need to recognize that there's a direction then associated with the arrowhead. Anything to do with a triangle, we're going to be using SOHCAHTOA, but also, of course, Pythagorean theorem. And we're going to be recognizing a resultant which comes about by analyzing the x and the y. So, question 4 on page 137 is a cyclist leaving home and riding 3 kilometers due south. So I'm setting myself up with a little reference point here, and due south is easy because it's just straight down. I recognize that I am going through my big ideas. I'm doing my vector, tail to tip. I'm adding them together, and I've got my arrowheads in place. This one is 3 kilometers. Easy. Okay. I'm actually going to be adding these together as I go. So just to make it a little bit more logical, as I'm going along, I'm going to add my x's and y's. And I'm going to try and use a different color for both. So I'm going to use green for the y, and I'm going to use blue for the x. So arrow number 1 here, so I'm going to label this arrow number 1. Arrow number 1 is 0 in the x.
Please come to the office. Edison Lee, come to the office, please. Thank you.
So there's 0 x component of this arrow. Whereas the y component is 3 kilometers. So I've got a 3 kilometer component here, and it's down. So I've got to remember, if I'm talking about north, south, east and west, I'm going to say down is negative. So south is negative. So I'm putting that negative sign in there, and that's key. That's a big idea to do with x, y analysis. I'll put that on here as well. Positives and negatives. Got to keep track of them. Okay, easy so far. We're going to keep going. The next vector is 5.5 kilometers on a bearing of 110. So I'm doing my little reference grid again, and I need to take a bearing of 110. Well, a bearing starts from north and goes clockwise, right? So 110 is going to go past 90 to here, and it's 5.5 kilometers there. This is 110, and I'm going to be interested in the triangle, so I need to know what this angle is in here. So 110 minus 90 is 20. So I can kind of get rid of that angle there and just leave it as 20. And if I really wanted to, I could put that angle in as well, because that's going to be 70. Okay, let's keep going. But let's first of all add these to our xy analysis. This is arrow 2. So let's put that in here. Arrow number 2 is, well, it has some x and it has some y. So let's put the x bit on. This is the x vector with an arrowhead, right? And I'm going to label that x2. And we can even work that out right away. So this is the hypotenuse, and I need to know the adjacent. And that's the angle that I'm going to use, the 20. So I'm going to use my SOHCAHTOA. I've got my hypotenuse, I've got my adjacent and my angle. So I'm going to use cosine. So this is going to be 5.5 cosine 20. And it's a positive because it's going to the right. So I'm going to do that calculation, on here. I'm going to go 5.5 cosine 20, and that's 2.2444. So I'm just going to put that in, 2.2444. And that's going to be kilometers, because that's my unit. Okay. The y component is here. So I'm going to call this y2, and that's going to be another negative, right? So I've gone down here and I'm going down here. So these are both negatives, and it's opposite. So hopefully you can realize now it's 5.5 sine 20. Okay, and if I put that in, 5.5 sine 20, 5.0211. 0.0211 kilometers, and it's negative. All right, so far so good. Next one. It's the third arrow on here, and it's going 2.9 kilometers, and it says 40 degrees east of north. So that's north, and I need to go 40 degrees east of north. So my arrow is here, and that there is my 40 degrees. Okay, so that's my arrow there, and I'm now going to analyze for the X and Y on this, and I'm actually going to do this side just because I've got a bit of a mess going on here. I'm going to use this side, and I'm going to use this one here. This is X3, because this is, of course, my third vector here. This is my third vector, so that's X3, and this one is my my Y3. Okay, so but I'm going to use this angle, so I need to make sure that I do the conversion. If that's 40, this must be 50. So as we go through, we'll see if we can add them into here. My third vector in the X is adjacent, and the actual size of this arrow, which I forgot to put on, is 2.9. So 2.9 kilometers, and so I'm using my hypotenuse and my adjacent, so it's cosine, and it's a positive, so positive 2.9 cosine 50. So that's my angle, it's my adjacent, my hypotenuse. So let's get the number for that. 2.9 cosine 50, 2.7984. 2.7984 kilometers, and it's a positive. Okay, let's do the Y. The Y is also a positive, which is the first one that we have, right? So we've got this one and this one, and these are both negatives, but this one's going to be a positive because it's going up, and it's opposite, so it's going to be 2.9 sine 50. Okay, let's get the number. 2.9 sine 50. Whoops, did I press something wrong there? Let's try that again. 2.9 sine 50. What did I do there? Let's just check. Oh no, I'm in radians. Disaster. So I might have to redo my calculations. That's okay. 2.9 sine 50 is 2.221. So 2.221 kilometers. Let me just go back and check these values, because that was definitely in radians, but I might have accidentally put it in radians when I hit the wrong key. So 5.5 cosine 20. Yeah, these are all wrong. So I've got to change these because I was in radians. There's a good lesson for us, folks. Make sure you don't have it in radians, otherwise you're going to get yourself hooped. So just excuse me while I put these in. This one, 2.7, oops, 2.9 cosine 50, 1.864, and then up here 5.5 sine 20, 1.88, use green, 1.88, 1, 2, 2, these are all kilometers, and then lastly 2.9 sine 50, 2.221. Okay, good, we fixed the problem. It's another good reason to write everything down, right? So if you do make a mistake, you can go back and just quickly check that where you've made that error. All right, last arrow. I'm kind of getting myself in a bit of a mess here, but let's see if we can do it anyway. The last arrow, I'm kind of going to go into here, but I'll be able to add it up either way, is 4.5 kilometers on a heading of 20 degrees north of east. So once again, 20 degrees north of east. Well, east is there, 20 degrees north is going to be to there. So my arrow is right in there, and that's 20 degrees. And it's 4.5 kilometers. Okay, so I've got my X, which I'm going to put up here, and I've got my Y, which I'm going to put here. Okay, now, so I need to just make sure I convert the angle over. So this is going to be 70 degrees because I've got to make that into 90. And so my fourth arrow here is going to be, okay, I've got 4.5 as my hypotenuse, and I need the adjacent for my y. So the adjacent for my y, so 4.5 cosine 70. It's going to give me my y. 4.5 cosine 70. So that's 1.539, and that's a positive as well. So that's my value, that's my value, that's my value, and that's my value. I'm going to add all these together in a minute. Okay. My fourth arrow in the x is up here. It's opposite this angle, so it's sine. So it's going to be 4.5 sine 70. So 4.5 sine 70 is 4.228. And it's also a positive. So there's my value, there's my value, there's my value, and 0 is also my value. Okay, I've done all the hard work. Now I just have to turn this. I'm going to add them all up, get an x total and a y total. And that's going to give me a new triangle, right? So my x total is going to go basically from here across to somewhere over here, and my y total is going to come down to here. So my new triangle is going to look something like this, with this being my x total and this being my y total. And the key is that this new vector arrow gives me the displacement in here, which is this displacement here, and then I can get the angle, I can get the sides. So let's add those together. We'll actually have the values written down somewhere, but we'll do it anyway. So 0, of course, plus 5.168 plus 1.864 plus 4.228. Okay, so my x total is 11.26. I'm just going to put that right in here, 11.26 kilometers. And my y total, -3 plus -1.881 plus 2.221 plus 1.539. Okay, so that's giving me -1.121, and that's a good sign because I wanted it to be negative, right? I wanted it to come down. So I'm going to put that on here as 1.121. Notice that I haven't put the negative sign in. Okay, I've left the negative sign off because I've got an arrow going down. I know that's negative. I don't want the negative sign in here when I do my trigonometry, right? Otherwise it's going to mess up with my SOHCAHTOA. Okay, this resultant then is going to be Pythagorean theorem of these two values. Okay, so pretty straightforward. We're going to go this value squared, 11.26 squared, plus 1.121. Remember, don't put the negative sign in. Squared, okay, and then you square root the whole thing. It gives you 11.31 kilometers. Okay, let's just double check our significant digits. That's to 4 significant digits, and looking at the question, the smallest value we had was 2. So my answer here is going to have to be to 2 significant digits. So I know that this is going to be 11 kilometers. 11 kilometers is my answer. Now I just need a direction, right? Because big ideas, if I have an arrowhead, I need a direction. Okay, so I'm not done yet. I still have to figure out the direction, which means I need this angle here. I'm going to use these two values with my tan ratio. So my tan ratio, because this is the opposite and this is the adjacent. So I'm going to go 1.121, I think it was, 1.121. Not putting the negative sign in, even though we know it's a negative, but that just indicates it's going down. So 1.121 divided by 11.26. Okay, so that's opposite over adjacent, which is my tan. And then the inverse tan of that's going to give me the angle. Okay, so 1.121 divided by 11.26, and then I'm going to inverse tan the answer 5.68. Okay, so this angle here is 5.68. Remember, I've got to go to 2 sig digs. Got to be the same, so it's actually 5.7. Okay, so 5.7 degrees, but I also have to communicate roughly what's going on, right? So I could say that this was a bearing. A bearing would start here and go this way, so it would go 90 plus 5.7. So I could say that it's 95.7 bearing, or I could say that this is 5.7 south of east. So I'd probably go with that, south of east. Both of those would give you the right answer though. And that's how you do it. It's a lengthy process. There's many steps going on in there, but if you stick to your big ideas, if you keep coming back to these big ideas, you can't go wrong. And when you write it out, write it all out like this so you can see if you make any mistakes, get your diagram in place, and you should be good. Everybody happy? Clear as mud? Excellent.